Hello everyone. So today we continue from our previous video. So we have our warehouse here, and now we continue to model this and put the loads and set some property, and then we can proceed to run the analysis. Now I want to change the display of this model, so I click on the small button here. One more way is you can right click on the model view here and then click on display. I will turn off the grid and apply, and then I go to bars and select the sections legend by colors. So I apply. Now the member will change the color and sort by the section, and it show you at the bottom right of the screen here. And as you can see, we have blue, green and other color uh, following our section. So now I close this. Next I'm going to put the bracing. So I will create one more section, but first I'm going to click on this. I don't want the section that not using the model here. Now I create one section, and for the pressing I will use cable. So the section should be round here, but it's not hollow section, so I select on solid and let's say this cable, and I will use the 20mm. We will not design this cable, so you don't have to worry about the material here, but you can change to the material like steel. It's okay. Now to draw the cable, I use the bar type simple bar again, and this is the section is cable. Now for the beginning, I can click on this and click on the top of the column. So this is our bracing. You can draw the same to the other side, but I have another way to complete the bracing. So I only draw one side. I think I should turn this off in order to easy to draw. Now we complete one side. We can right click on the cable and then go to select similar. You can select by cross section, and I use the vertical mirror, and the plane again is the YZ, and now you can click on the reference point. So now this is the pressing for one span. So I select the similar again, and I will copy this to the other span. Let's say it's one here. Okay, so this is our bracing. Now I want another bracing at the end frame here, so I will draw this again. Now we copy this, but you cannot use select similar anymore, because if you do this, all the cable will be select. So if you want to select this, you can manually click on one of the cable here, but another way is you can click on the select similar, choose cross section, but this time you create a window by clicking on this button. So it will show you only the cable, and then you can go to front and select this section. You can close this. Now only the cable at the end frame is selected. So now you can copy this to another end frame. Now we got our bracing. So to be sure, I just select all the node and click on delete button to make sure that there is no uh, no isolated node in our model. Now I want to put the support, so I select all the node at the bottom of the column and go to supports here, and I want to use pin. Click on pin and apply. Now the pin appear, and if you want to show the support again, you can click on this button. Now we got our support, but we need to define our cable as cable, because this is just a simple material. It's not act like a cable, so I'm going to select all the cable here and go to geometry, additional attributes, and advanced bar properties. So now the cable only act the cable only use it only resists the tension force. So I will select on the tensions bar option here and apply. So the cable will resist only the tension force. Now I will draw the cladding. So I go to geometry and claddings. I will use one-way X direction, and first I'm going to draw the cladding on the side. So click 3 point here, and the cladding is already drawn, but it doesn't show because we turn it off. So now you can click on this small button. So this is the cladding that I draw. Next I'm going to draw another side. In order to make it easy to draw, I turn the section shapes first, turn it off, and now I draw the cladding on the roof. So the only cladding left is at the end frame. Now for this cladding I will use contour. So now our cladding is complete. Okay, now uh, we we can put the load on the cladding here. So first I'm going to select the load types here and create the load type. So first I will call this save. So I name this as save, and the nature is dead, and the other one is dead load. So let's just call this EL. The next will be roof line load. You can select the live here, but if you want to use the roof line load, you go to snow and change the subnature to roof live, and I will call this LO. So now we got our three load types. Next I'm going to select cladding on the roof. I'm going to put the load. So this is the uh, roof line load. So I will use the local, and for this load I will use only 0.3 kilopascal, and the direction is negative. Keep in mind that this load you need to follow the standard that you follow. And now I will put the dead load to our roof here, and for this case I only use 0.1 kilopascal, and the same, the direction is negative. So now our loads are placed on the cladding. Next I'm going to run the load simulation, the wind load simulation. So click on the wind load simulation here and go to generate wind loads. Now I will only select only two direction, because this warehouse is symmetry, as you can see. So only two direction is okay. Now for the wind load I will use something like 30. This is depend on your area, so you need to make sure that the input that you put here is okay for your project. Now I select all the cladding here and copy the number and put the name of the cladding here, and I will keep the wind profile the same. Now I start the load simulation. Sometimes it takes a while, so just be patient. Okay, now the simulation is complete. To make sure that your cladding is distribute the load correctly, you can check by go to analysis and generation of computational model. And then you go to display loads and select on the load distribution regions and apply. So this is how the load is distributed. So it's not correct for the case here, because the cable will take the load from the cladding also. So now I will turn I will change this. I will select on all the cable here. I don't want the cable to resist the load from the cladding, so I go to geometry and additional attributes and load distribution options. I copy the number here and paste here and click Enoch button, close. So now you can do this again. So this is now how our load is distributed. So now only the column rafter resist the load. It's okay now, so I'm going to turn this off. I will turn off the cladding. The first click, it will not turn off. So you just turn off another option, so the program will turn the cladding off. Now I want to show you the load the analysis tab. You can go to analysis and analysis tab here, or click on this button. So the analysis tab will turn here into the nonlinear static, because normally it is the linear static, but because of our cable here is tension only member, so it automatically change the analysis type here to nonlinear static. So you have to check that to make sure that it is the nonlinear static. Now I want to offset the column and rafter here. So you can go to geometry and additional attribute and offsets. To make it easy to change, you can select similar by materials. So only the main frame and end frame are selected. Now you can go to new window and you can change it to upper flank. So now it offset following the upper flank option here, but some column is not correct, like this one. So I'm going to front. I will select this. You can change to lower flank, but I don't want to do that. I want to rotate the column instead. So I'm going to properties and gamma angle and change this to 100 uh, 80 degree. So now the column is okay. Next, I don't want to change the column. I don't want to offset the column at the mainframe here. So I will select the inside column like this and click on delete and apply. So now I got what I want. So if you want to show the offset, you can go to display again and click on offsets, apply. So now the model is showing the offsets. Okay, so right now everything is complete. Now you can create the load combination. So you can go to loads and automatic load combination, or you can create a manual load combination, but I don't recommend this because it takes a lot of time. So I will go to automatic combinations and manual combination generate and click on more. You can create the load combination uh, following the ULS. It is the ultimate state, the serviceability switch state, and this is the accidental switch state. In this case, I only create the two state here, the ultimate limit state and switchability limit state. So I'm going to click next, and I want to select all this case here. So I click on the button here. This is select all button. So everything is selected, and click on generate. Now the load combination is generated. So everything is fine. Now in order to run the analysis, I want to show you the option here, the direct analysis method. For this video, I will design following the direct analysis method. You can check this method in the AISC. So now I select this and go to set parameters. So if you want to use ASD, you just click ASD here, but in this case I will use LOFD, and I will select the apply additional notional load, and this option will select automatically. And now everything is done, so I click OK. So now you can run the analysis. You can click on the calculations. So this is going to take a while. Okay, now the analysis is complete. You can check the information of the direct analysis method report here. I'm not going to detail this. you have to check the AISC for this detail. Now what you need to do is you check the analysis in order to make it to see if the analysis is okay or not. So I'm going to result and results here. I will maximize this window. Next I'm going to show only the main frame, so I'm going to select by material and I will turn the section shape off and also the offsets. Now the first thing is I'm going to show the moment. So this is how the moment how the member take the moment. So this is a safe way. Next you can check the light load and you can check the wind. Also another direction. So the moment seems okay now. I'm going to turn this off. And next I'm going to show the deformation. So I go to the deformation tab here and click on the deformation and normalize. So to turn the structure, the original structure off, you can click on the small button here and then click it again. So this is how the structure is deformed. This is safe way. If you want to know the value, you can go to parameters, labels, and go to deformation again, normalize, and this is the value of the deformation. Next I'm going to show the visibility combination for dead load plus live load. So you can see here 1 2 3, and this is the load for 1 2 3 here, and the factor is 1.0 1.0, and for the live load is also 1.0. so you can click normalize again. So this is the deform shape following the serviceability load combination dead load plus live load. You can also show the dead load plus wind load combination here. Also one another direction. And if you want to make sure the deformation is okay, you can turn on the animation, but first I'm going to turn this off first. You can start the animation here. So as you can see, it's look okay. You can change to another combination. This is the load plus wind load. Now you can start the animation. So the structure analysis seems to be okay. Now I'm going to turn this deformation off and click on the small button again. So our analysis is okay. So the first thing is you can check the serviceability design you can check with the limit value of the deflection, or you can go to still design for ultimate limit state first. It's up to you, but I'm not going to cover in this video here. So I will just show you only the result, the analysis here. Next, I'm going to show you the reaction. So you can go to the reaction window here, and this is the reaction or for every node and every cases of the load and load combination we have. You can select load combination that you want to show, like this is the load class line load. So now the node, every node here in this table, and this is the case. It shows you only the case 24 here represent the serviceability load combination, and this is the value for reaction load. And as you can see here, the moment is 0 because we use the pin support. And you can check every node in this table here, or another way you can go to XY view like this, and this is the base level. It is 0 met, and you go to reactions, and you can show the 3 axes here. You can turn the moment on, but it doesn't matter because there's no moment. And next you select the descriptions and normalize. So this is the reaction. Now I will change this to the load combination number 24. This is dead load plus line load, and so this is the reaction load. The Z direction is upward. You can change it to 3D also by clicking the small house button here. I will turn the section shape off, and also the offsets. So this is the reaction load. You can also check the direction of the reaction load as well. As you can see at the arrows for the reaction load here. You can show the load combination with the wind load, and this is for the other direction, and this is for all the load, dead load plus line load and plus wind load, and this for the other direction. So you can take this result and design the foundation following this result. So now I'm going to turn this off. We turn this on again. So our analysis is complete. Next, I think I should show you the cable, because it is the tension only. So I'm going to show you is it correct or not. So I will turn this on, so there is no load here. I will turn this fx, so there is low. This is the tension force on the cable. For shear, everything is 0. So for the cable here, it is correct. You can use this result now. I'm going to close this window. Now I will go to steel design. So for the steel design, you can design following the ultimate limit state and serviceability limit state here. And if you want to know the limit of the serviceability limit state, you can go to configuration. I think it's not here. uh, I think it's something in the member type here. So you can go to service, and this is the serviceability limit state. You can change the number here, but for this tutorial I will not use this option here. I will only design the steel using the following the ultimate limit state only. And for the serviceability limit state, I will check this using the result from the structural analysis directly. So I will show you in the next video, and for now I will stop here, and I see you guys in my next video. Thank you for watching.